Now I'll show you how to segment objects with EdgeTAM. So this is basically a lightweight version of SAM2. You see positive prompt here and segmentation. And in this image, there's no prompt, but segmentation is performed, and you see the cat, eyes, and pillow. And I have one more example. There's that, yes, here. Yeah, you see the cat here, and you see the tail as well. It's segmented. So as I said to you before, this is lightweight version of SAM2. Let me explain this. Yeah, there's one image, and you see the performance comparison between SAM2 and EdgeTAM. For example, on iPhone, it's more than 20 times faster, and on GPU, you see it's like more than 2 times faster. You see the FPS values here, for example, 150, and in SAM2 it's around 60. So you don't have to have powerful GPUs to run these EdgeTAM models, and even if you don't have any NVIDIA GPU, you can still run these models on CPU. So first I will start with, how to create a proper environment. Then I will show you 3 different demos. Segmentation on image, segmentation on video, and last one, automatic mask generator. So this works without any prompts, like this cat example. So we can start with environment part. So I strongly recommend you to create an Anaconda environment. Then you need to install these. If you have NVIDIA GPU, I strongly recommend you to create a GPU supported PyTorch environment, because it will be like faster than CPU version. You can follow this article to create GPU supported PyTorch environment. I explained every step one by one. It's not that hard. But anyway, if you don't have like NVIDIA GPU, you can follow default installation. So you can go to this EdgeTAM GitHub repository, and you can follow this. So first, I assume that you install PyTorch with GPU support or not. After that, you need to clone this repository, EdgeTAM. Then you need to install few more helper libraries. And I already did that. Let me show you my environment. Let's create new notebook. I'll name it as main. Oops. Okay, you see here EdgeTAM env, and let me show you versions. Oops. Yeah, we can ignore this warning. And you see this says CUDA is available, says true. So this environment is GPU supported. And let me continue. Yeah, there will be 3 different demos. By the way, you don't have to, follow this. You don't have to copy these codes. There are 3 different notebooks inside this repository. You see your EdgeTAM notebooks. You can directly follow these notebooks as well. They explain everything step by step. For example, this is image predictor example notebook. It shows you, how you can segment objects with positive and negative prompts, like bounding box prompt here, for example. You see this is negative prompt, so you only segment it higher. Yeah, for example, multiple prompts. And this is the same for video predictor example. You can follow this as well. But I will show you everything step by step, so it's up to you. Let me continue. First, we need to import few libraries. And before that, you have to download model file. And I think, yes, here, go this repository, EdgeTAM. And there has to be link, yes, here. Click this link. Model is available here, you see here. And click this download raw file button. So it will directly download it. I already did that. And I copied my model file under this checkpoints folder. You see here. And let me continue. Yeah, it says using device CUDA. Perfect. Yeah, these are like helper functions to visualize masks, points, and bounding boxes. I don't have to explain these. Not that important. Okay, now let's load the model. And you see here checkpoint. This is model file and this is config file. And you can find this config file inside, I think, SAM2 configs. And yes, here you see there are a lot of informations. I think you can change some of these parameters, but I'm not sure. Yeah, you don't have to change this, but if you are interested, like, you can try. Okay, you see here we built the model and we created the instance of the SAM2 image predictor class. You can see the implementation from this SAM2 image predictor file inside the SAM2 folder here. Yeah, you can see the parameters, arguments. So we will use this instance of the SAM2 image predictor class for inference. But before that, we need to read image. And we set image for prediction. Yeah, you can check this method as well. it says like calculate the image embeddings for the provided image, allowing mask to be predicted with the predict method. Perfect. Yeah, this is inside same file. You can check source code. And after that, we have to provide prompts, and there's not one prompt type. You see here positive, negative points, bounding box, and mask. I'll show you first two. Okay, so you see here, this is positive prompt because you see here this label is 1, and for second point, this is 0. This means negative point. So this is x and y coordinates, and we are using this predict method. And for displaying, I use matplotlib, but you can use OpenCV as well. So this is positive prompt, and if you delete this, you can see coordinates as well. Yes, you see 600 to 400, first point, positive prompt, and this coordinate, it's here, you see negative prompt. Yeah, it's like this, you can add as many prompts as you want, and you can combine bounding box prompt with point prompts as well. I think there's one example, yes. Yeah, this is only bounding box. For example, let's say we want to, segment elephant on the right with bounding box prompt. So we have to assign bounding box coordinates, top left and bottom right. So top left will be like 800 to 300 here, and bottom right will be like 1250, like here, and 60. Not precisely, but I think close to that. Yes, you see here. By the way, this is by default, this is positive prompt when when you provide bounding box. And if you want to combine this bounding box prompt with point prompt, positive or negative, you can check this notebook for that. Right now I only show you the basics, but here, let's find that. Yeah, for example, here you see this bounding box is positive prompt and this point is negative. Let's see how all it's done. Here you see point coordinates. Label is 0, so this is negative prompt, and this is the coordinates. And for bounding box, you only, pass this into this box argument. You can combine like this, and this can be positive prompt as well. If you assign this to 1, it will segment all of these tire, not only this outside part. So you can combine like this. And let me continue. Yes. And now I'll show you how to track objects with EdgeTAM, but it is not exactly tracking. You will see in a minute. And I want to show you directly from this official notebook. Let's go step by step. So they say first you need to select an example video, and you need to store all of the frames into a specific folder. Yeah, you can use FFmpeg or OpenCV, it's up to you. After that, you need to load all the images to the model at once. And this is not like classical object tracking methods, because here you have to load all of the images at once, so you cannot use this model with live streams. So this is not exactly like object tracking, because you have to load all the frames into model at once, and it processes all the frames, then you see the result. So this is not that efficient for tracking. And there was some issues about this topic on GitHub as well, on SAM2 repository and EdgeTAM. You can check these. Some people recommend different ideas, so you can find something maybe. Like they said, you can assign prompts one by one, frame by frame, with just like this image predictor example. For each frame, you can assign points, then you can try to track objects. But anyway, let's continue. Okay, let's say video. Yeah, as I said you before, you can use FFmpeg or OpenCV for saving frames. I already did that with FFmpeg, and you see here my frames for cats video. Yeah, you see one by one frames. Yeah, look at the cat. I think there are around 200 images. Yes. So we will load all of the frames at once. Let's create inference state. So you see here we are loading frames. Yeah, you can check source code for this video predictor as well. Yeah, it's inside this build SAM. Yeah, it finished. So now we have to assign prompts, just like in first example. But we have one problem. This frame names. It's not that important. I will delete this part. That was only for, displaying the prompt. Okay, I added few lines to display first frames because this is not updated as well. I will update this blog post as well. But this is not important, just for displaying this frame, I added these lines. And here, again, we define prompts, and we have 3 positive prompts here. For example, 400 to 250. Let's check 400 to 250. It's around here, head of the cat. Second prompt, 500 to 220. 500 here to 220 is around this. So using these 3 prompts, let me run this. But no. And now we will propagate through video. And there's some, method defined here. So this might take some time depending on your GPU or CPU. And it saves all of the, segmentation result to this dictionary. And after that, you can use this dictionary to process further, like you can save it to MP4 video, or it's up to you. And yes, this is the result. And let's say you want to create a video, you can use this script. I didn't add this to blog post because it's not that necessary. Yeah, so you basically, using this dictionary, you extract the segmentation information, then save it to a video. Okay, where's the video? Yes, here, output video. Let's check it. Here, this one. Yeah, we defined 3 prompts. Head, and here, I think. And you see the segmentation. Yeah, you can add prompts, you can add more prompts, or, you can add negative prompts. It's up to you. You can add bounding box prompts or mask prompt. I think there's one last demo. Yes. Yeah, in this one, you don't have to provide any prompts. You'll see, this is SAM2 automatic mask generator. You can check the class implementation here. So using a SAM2 model, generate masks for the entire image. You see the parameters. This might take a long time depending on your GPU. Let's choose different image, maybe this car, or I don't know. Yeah, let's choose this cat. Okay. So after 1 minute, it finished. Now let's display the result using the cell. Yeah, you see, for mask, one is entire cat. There's 2 eyes and 1 pillow. And I think that's it for this video. Thanks for watching. See you soon.